Hi folks, today we're going to talk about the SAM approach and the subboarding for SAM approach and Kotlin. So what is the SAM approach? SAM approach is just an interface that includes single abstract method only single abstract method, only one. Okay, so let's start with creating an interface, a normal interface, and calling it event bus. And let's make that event bus generic. It's just a normal interface, as you can see. Now, and to make this interface supporting for SAM approach, all we need to do is just write a fun modifier before that interface. Now you got a warning message. This message took that functional interface must have exactly one abstract function. So that's what we gonna do right now. So now we just need to create a function. Let's call it send. Okay, and this function take as a parameter data of type T. Okay, just as you can see, just interface holding just single abstract method, and it just the new thing is just putting a fun modifier before the interface keyword. Okay, now we're gonna make a class, a new class, and call it messages handler, just like that. This message handler, it just normal class will take event bus as an parameter. So just event bus as a parameter of type string, of course. Let's make it a string that type T. Now here inside that class, I'm gonna make just a function for this is just for a demonstration purpose. Okay, so here fun send msg, send a message, send message, and here we need just here message of type string, like that. Now in this function, inside this method, I'm just calling event bus dot send, and here I'm gonna send that message here. So we are here, we just sending a message from messages handler. We are sending a message to send inside the event bus, okay, so the send inside event bus will receive this message from the send message handler inside a messages handler. Okay, so now let's go to the main method here, and inside it let's make a handler val msg handler call messages handler. And here's the thing. Now to passing an interface, of course we all know that we cannot actually create an instance of interface. The main way to do that just by making anonymous class or anonymous object. In Kotlin we do that by call object, which is anonymous class, and make it implement the event bus, the interface. And here the event bus, we are implementing our event bus here, and we override here the members, which is data. So this send function will receive the data that we are sending from a message handler dot send message. Here, if you say message handler dot send message, and let's say hello SAM approach, hello SAM approach. Okay, now inside this handler we'll send a message. The send function inside the event bus will receive that message here. So here we can handle that data or that message as we want. For example, let's print this received data, println, and here let's say from anonymous from anonymous, my MSG is, and call here data. Simply, let's run and see what the result be. What will the result be? And here, just run. And here, from anonymous, my message is hello Sam approach, right? So, okay, but you can see this is not amazing. This is not interesting. Like, this is boring, passing an anonymous object or something like that. So what we can do is just remove that and just open a curly braces, which is a lambda function here. So here we are telling the compiler here is the real and actual implementation for the send message inside that event bus interface. So the real implementation for this send function is here. So now we are receiving the data here, and we can handle it here. So just print, for example, print from lambda. From lambda, my message is data. Let's run this and see. From lambda, my message is hello Sam approach, right? And just this is really easy and simple. Of course, we can do that in a different way. This is just the simplest way to do that. But we can actually, of course, remove this lambda, and here, for example, opening a constructor for messages handler, and here we can say event bus equal, for example, event bus and opening the curly braces. But as you can see here, a gray color for event bus say and message, it will show you a message redundant SAM constructor and telling you to remove that redundant SAM constructor. Yeah, and that's it. So of course we don't know the simplest way to remove all these redundant thing, and just opening a curly braces and a lambda here and handle that message here just like that. It, or you can name it here, of course, lambda, can name it as you want, and here data. And just now let's say let's give you a real example from real world about SAM approach. And I'm not telling you, I'm gonna give you a simple implementation for LiveData from Android. And if you're an Android developer, of course you should know about this topic, LiveData for state management inside the view models and so on. So I'm not telling you, I'm giving you the actual implementation for LiveData, just a simplicity and a simple implementation for the LiveData. So here I made LiveData class previously, and here is it. So class LiveData, take a generic type, private var. We have two property, which is a value of type T and nullable value here, and the next one is observers, which is array list of type observer of type T. So the observer here is just an interface, SAM interface. It is a functional interface which has just only single abstract method, which is on a change that takes a value as an parameter. So and here let's back to the LiveData, and here we have some functions here. First one is observe, which is the main function here. The observe here is actually the function that notified this observe will notified with the new value that are coming to the LiveData. Okay, so we'll give you or notify you with the new values for that LiveData here. So it just check if that observer is not contains in the array list here. So add this observer and then notify that observer with the new changes by calling on the change and passing the value or the new value for it. Okay, then we have remove observer to remove that observer. We have get value to getting this value, and we have the setting value. And before set value, let's go to the next function, which is notify all observer. This is important function here. So this iterate overall the observers and notify them with the new values or new value for that live data. So here observer dot on a change dot give it the value. Okay, so iterate overall observers and notify them with the new value using on it changed here. So setting value, once we are setting a new value, we should notify all observers that subscribe or listen to that live data, right? So we have here if that value, if the new value not equal the old value, so update the old value with a new value and then notify all observers with that value here. Okay, so this is a thing, and this is how live data works underneath the hood. Just a simple implementation for live data, not like a real one. Okay, so this is just for demonstration purpose. So now if we go to main, let's commit this code and let's this. We have here a live data instance of type string. So here I'm using live data dot observe, and this observe, as I said before, it notifies you with a new values that are coming from live data. Okay, here, so and here I'm iterating from 1 to 100. Okay, and then I'm using live data that set value and putting a new value here. So once I putting a new value, the observe here notified with that a new value and give you that a new value. Then you can handle it as you want, print in it and make process about on it, whatever you want. And here just using thread sleep to make a simple delay to make the result showable here. Let's open the console or play here. Let's make a run to see the result. And here number 1, number 2, number 3, we are printing the value, printing the value here. So we are sending a setting value here, and we are notified with that value here, and print it here. So here, as you can see here, 18, 19, 20, 21, 22, and yeah, this is simple. And peace. Okay, by the way, in the next incoming video, I'm going to show you another real example for a SAM approach, and we will implement the flow, Kotlin flow, and we're going to show you how the Kotlin flows work underneath the hood. Okay, and we're going to answer a question, which is, does the Kotlin flow synchronous or asynchronous in natural? Okay, so I'm waiting your answer about Kotlin flows, and answer the question if it is asynchronous or synchronous. And just peace.